Hello and welcome everyone to the Fairchild Republic A-10 Thunderbolt 2 live print, where we go over the settings for Aero ASA Aero from Bambu Labs. It's specifically from Bambu Labs. I'm using their filament, I'm using their ASA, and I'm going to give you a moment over here on this side to go over and look at the settings, because the settings I put out before, you'll have to excuse, there's a very upset husky in the background because he's not in here yet. I'm going to go off mic here in just a minute. I'm going to let you go through these settings. I'm going to scroll through each one of the tabs, and I'm going to let you look at what's going on. Specifically, the slice gap closing radius. And the reason why is because the lab print planes don't recognize, or you miss walls inside the model when it's at 0.2, which is one of the recommendations for ASA. So I found that out earlier today. So that's a good tidbit of information. So go ahead and look over these settings. We're going to be starting the print with this little guy right here, this little wingtip, and we are going to test it, and I'll show you why in just a minute, why we're using this part specifically to start off with the demonstration. So go ahead and look over these settings, and we'll be right back. And if I go too fast, don't worry about it. You can always go back and check it out. No supports on this one. Okay, so now what I'm going to show you is the reason why we chose this part. We're going to go into preview mode because I've already sliced it. It's already set up for the Aero. I think it's the Buy My Coffee website. Yeah, that's the one. These settings are on there for the filament and for the printer settings for the X1 Carbon, and they are there. They're free. You can download them in the shop. And just remember to replace that slice gap, the closing slice gap radius, down to 0.01. Otherwise, I noticed in the canopy that I was missing some walls. So when I brought that from 0.02 to 0.01, it fixed that issue. So the reason why we're using this particular model is because of this. This is what I wanted to find out about. Now, on most of the PLAs I've used to try and print this, it's come out pretty horribly. So since this is a slow printing expanding foam, the reason why these settings are the way they are is for the fact that it expands. What we're going to do is we're going to go ahead and run this print. It'll take 25 minutes, then we'll inspect it. Remember, this is ASA, straight out of the bag, right into the AMS. I've got brand new desiccant packs in there. It might take a little while to get the moisture down in the cabin, but everything's good. It should be dry enough. Tomorrow, I'm going to do the same thing. I'm going to run another part or two, and then I'm going to make absolutely certain that it's dry. So I'm going to dry it tonight after I'm done with this print. So what we're going to do now is we're going to send this over to the printer. We're going to watch and see what it does. I use an engineering plate. I use hairspray for my adhesive. It is a really good adhesive. You spray it on. Usually the Rave stuff is really good. And you just smear it with your hands and make it flat. Do a couple layers of that on an engineering plate and you're good to go. So let's send this print over. Let's get it started so you can watch it, and we'll see what happens together, because this should be interesting. ASA Aero from Bambu Labs, A-10 Fairchild Republic. We are doing its first part right now. So here we go. Oh, one other thing I wanted to note is do not check flow dynamics calibration. Because we're doing a different extrusion modifier inside the actual filament settings, you don't want it to go through flow dynamics to calibrate itself on the flow. So you're going to uncheck that before you send it over to the printer. It's going to go through its normal setup process where it calibrates itself, except for the extrusion, and then it's going to get started. So hang in there. We're watching this live together to see what happens. This is kind of a slow bed heat up. I haven't had it take this long to heat up before. I don't know. I wonder if it's because of ASA. Not sure. Looks like it's getting ready to go. I haven't run it in a while, so it took a little while for self-calibration, but now it's doing its bed leveling. I'm just happy I never have to bed level again. As far as the fumes go, they haven't told me that they are going to be toxic to me if I'm printing indoors. It does have a carbon filter in it that's supposed to take care of the fumes. I haven't really smelled anything while printing with this thing ever. Tis looking a little messy at the moment. Could be because it's wet, but we'll see what happens. Or that could have been just drip. It's gonna play Pong with it, watch. All of this might be a product of the fact that it's that it came out of the box, hasn't been dried yet, and this is what we're doing this for. So we're gonna see what happens. I had to grab that. I had to grab it. It was bugging me. Now the LiDAR is going to come back across. You know how this works. It's going to scan it, and it's going to make sure that the first layer is appropriate and continue. Look at that little string hanging on there. Time to probably change that rubber boot off that hot end. But, hey, it's working. A little bit of flashing here and there. I mean, who hasn't had to do post cleaning on something that they pull off a printer, right? After this is done printing, I am going to pull it off the bed. I do have a second camera set up so we can inspect the quality of it as it is right out of the box, and then we're it's just going to drag that mouse tail all over that thing. It's funny to watch. But we'll check the quality of the print now, and then we will check the quality of the print after a 12-hour drying cycle, and we'll compare both of them tomorrow, right after we do the second print. The expansion ratio, I don't remember the numbers off the top of my head. All I know is that the flow rate had to be anywhere between, they recommended 0.5 to 0.7. And I have found that looks like 0.48 is a little bit better. But we're going to find out. Again, this is printed wet, so we will see if there is a difference after the drying cycle. The humidity is 2 in the AMS, and I just put in 2 brand new desiccant packs, so we're good on that. Sorry about that. Ever since the update, I may have to find it in general settings, but what it does is it tends to shut the camera off on me after a certain amount of time. It never did that before the last update. Okay, so far with the 048, it should be a expansion ratio of roughly 211%. I'm sorry, I'm at my temperature. I'm running 280, so it'll be maximum foaming rate is 116, and volumetric expansion ratio is 216%. I haven't specifically used their LWPLA. That's why I wanted to try Aero, and I can already see that there's something going on with the layer gap, and so that could be an artifact of it being wet. I don't know, That's what we're here to find out. So you can already see it kind of failing on that steep slope transition on the gaps. So that's definitely not going to work for this. I'm thinking these end parts will probably require a resolution higher than 0.20 in order for it to actually print properly. I think if I printed it at high quality, it'd bring those layer gaps a little bit closer together. And this is what I wanted to find out. I think that's one. Yeah, I think that's one of the main things that I'm gonna have to deal with. As you can see that the vertical, for the most part, is almost flawless. But we'll inspect it after we pull it off, and then I think what I'll do is try and print it at a higher resolution. Probably the finest resolution I can get in order to get those flow gaps at the top closer together. We want the minimal amount of gap possible between those lines, because we're not supported at the end caps. So we could run minimal supports at the end cap just to make sure we hold up that top, but you know, I guess that's up to preference. I'm assuming that people print these at with an infill to a degree. Or they print the in pieces of the wingtips, like I said, they print them at higher resolution so that we don't have this problem. And again, this is wet. This is going like right from the package to the machine. So I'll try another one at a higher resolution, and what I'll do is I'll give it the finest resolution I can. I have a mad husky in the garage trying to get out. He'll be out in a minute. But what I'm going to do is I'm going to raise that resolution and see if it solves that gapping issue on those slopes. Because it seems like past 45 degrees is just going to start coming apart. I haven't tried this type, well, this part particularly with any other filament type because I was printing a lot of other stuff. But when you use the LWPLA, the question I have is, do you do it at a 0.2 layer height and get good results on parts like this with a heavy slope? Or do you have to raise that resolution to lower those gaps on those slopes? I think after this, what we're going to do is we're going to try it again, but we're going to try with a higher resolution to see if that solves the issue with this. So we may not end it tonight because I want to do both of them. I want to do this one at the 0.2 or 0.2, and then I want to do it at the highest resolution I can get, seeing that it's foaming. And then I would like to do them both again after they're dry at the 0.2 and the highest resolution. So we can kind of compare the differences and see how it goes. Because that's what I did this for, was to make certain we could actually give this a shot and tweak it together and figure it out. I personally see little to no expansion. I don't know if I'm wrong or if it's just a layer gap. Okay, so we're going to kind of take a look at it here really quickly. We're just going to switch over cams real quick and kind of take a look at what we got here. And as you can see, just like on the model itself, it printed fairly decent actually on the sidewalls. It was just that that vertical, that really steep slope, it just too much gap. So I think raising the, it's like really flimsy. It's like it's not cracking or anything like that. Oh, there it goes. It cracked. I spoke too soon. Okay. So some slight adjustments have to be made, but I think we're making some progress. Let's go ahead and do it at a higher resolution and do it again. So you guys want to hear like a joke? No, probably not. Just listen to the music and watch the video. No, if anyone okay, I'm gonna read the comments and then I want to kind of try and get back to you. I'm half blind, I can barely hear these things. All right. So how does the Ender 3 S1 handle printing the lab print planes like this? I honestly think it's just a problem. I'm gonna be, wow, it's purging the crap out of itself. You see that? The only thing I don't like about this one, it likes to purge a lot of material. I know it can be adjusted, but then it says you gotta watch out for internal printing pressures within the nozzle. So it's like, you gotta be careful. And that could also be, you see what you're seeing there? That could be from the fact that it's wet and it's expanding water and so on and so forth. So again, tonight we are going through that drying cycle, and then we're going to do this again. And this is at the 0.10 layer height. First we have to wait like it's the, you know, the DMV in order to let it do its setup. I don't mind it having to take a little bit more time like this, doing its own bed leveling, because 90% of my failures on an Ender 3 were because of having to manually bed level, because I never used the 3D touch and things like that. I just never did. No, I am not in Arizona. I am trapped in the bowl of California. It's okay though. If I stay where I'm at and the next earthquake comes, I'll have some nice beachfront property. Okay, so from what some of the data that I'm seeing, for example, if you're printing this at 220 Celsius, which is, I'm not sure why there's so many temperatures for ASA, because to my understanding, the temperature that I'm at is for the expansion ratio that I'm wanting. So we're looking at 216% on the volumetric expansion ratio at 280. At 220, you still get it, but you get only 100% expansion. 106 as you go up to 230, 240, 128, and so on and so forth until you get to 280, which is where I'm at 216% on the expansion ratio. You can hear my printer, it's like vibrating itself. Maximum foaming at the temperatures that I'm at is 116%. So, I mean, I'm no expert, but that didn't look like 116%. That would have been double the width of the extrusion, I'm assuming. So, minimum parts density 0.1 or 0.45. Maximum foaming ratio 116 at 280. Hold on. Volumetric expansion 216. Maximum foaming 116 at 280 on the nozzle temp. So okay, that's some good info. I think all people, and I'm not sure if it's just me, I think everybody who runs these planes, when it comes to those really steep gaps, you end up having this problem. I mean, if you do, you do. If you don't, great. If you don't, look in your settings and throw something my way. Because it's not doing, it doesn't appear to be doing the expansion. Maybe it is. I'm not sure. I mean, it kind of looks like it, but I mean, look at all the blobs coming off this thing. That's definitely got to be a product of it being wet. So when we do this again, we're gonna do it dry, and it's all this sounds so wrong. We're going to we're gonna do this again after I dry the filament. But did you notice it's got the same blob up there? The same one from just like the first one. There it is right there. I'm not reaching in to get it this time though. This is, but we are going to see a difference, I hope, because of the layer height. Yeah, it's going to take a little bit longer, but I don't think I'm going to have this kind of issue on mainly vertical sections. And I don't think there's much harm in adding some kind of either support or some infill with the Aero if you have to, in order to make sure that those steep top angles actually get printed properly. That may be something that I kind of play around with later on. But there's also the other side of it, that coin, where I don't think you should have to. I think you should be able to take the print settings the way they're supposed to be for the particular model, set the printer settings up, set the filament settings up, go by the recommendations for printing with this material, and then taking into consideration lab prints recommended settings for a foaming material, and kind of balance the two out to get kind of a perfect blend. But hey, I'm not against trying that LWPLA for that they sell at lab prints to see if it makes any difference at all in comparison to the Aero, or if there's any other things that I can do to make this print properly. Again, we'll see tomorrow when we double this process like we did tonight, and see if we get a change just from the drawing itself. I mean, a lot of times you think to yourself, how could, moisture cause such an issue in such a small little thing? I mean, but it can. So we're going to give it the benefit of the doubt. We're going to inspect both of these as they are, and then we're going to repeat the process tomorrow with dry filament, 12-hour cycle. it is a different possibility that it could get worse with the higher resolution, but that's what we're here to find out. I feel like it's printing too fast. I could be wrong, but if we're supposed to be doing a slow extrusion, maybe I'm wrong. You tell me. If you the planes that you print with the 3D lab print filament, do they print this fast normally or slower? This Aero filament, definitely not on the cheap side, I'll tell you that. But to be, perfectly honest, I don't mind doing this. I know, every part is a little bit less than I can print, but if it's not printing properly, it's not going to make much difference, is it? So if I do this and we all learn something from it, you guys have supported me by subscribing. The people who have subscribed, people who have shared, so that I get more subs. I mean, that's what I'm going for. This is what I'm doing. I'm working on this stuff 24/7, every day. Every one of my followers knows that when they leave comments, I answer them. Even if it's just with a thumbs up and I love the comment. But most of the time, I'm answering directly back to every single comment. This is what I'm doing every day. This is my work right here, and that's what the whole turbine design thing was for, and the Shrike concept drone and all the other stuff I've been working on. It's all a means to an end. But I also love flying RC, so I've got to get some more planes in the air. And I miss the foamies, man. I do. I miss like the Super Sky Surfer. And when I thought I found the body, I was ecstatic. And when I got it, it wasn't the big Super Sky Surfer like I used to have. It was the wrong size. And it's like, you can't find it anymore. And I missed that plane. I miss it. But I'm doing all this for you guys. I also got a balsa wood model over there in the garage that I'm trying to recover. And then that's going to have an electric motor on it. I like it. It's a good looking model. It just needs some care. What do we got going on the top here? Are you seeing that? That's a curious thing. We're gonna let it finish, see what goes on. Looks like that higher resolution is tearing up that that top right there. It's just not doing. I'm wondering. Let me try something. If I go down into silent, I can slow it down. Usually with filaments like this, it cuts the speed down to 50%. Still gives me the flow ratio that I started with. Doesn't affect that. So yeah, see, it's This could be just a product of wet filament, but look at that. It's just a mess. I gotta finish it though so we can see those top gaps, man. I'm committed. It's gonna give me a spaghetti warning here pretty quick. Even at that layer height, it almost bridged that gap. Almost. It's just eating itself. It still hasn't figured out that it's malfunctioning. All right, man. Thanks for stopping by, Carl. I appreciate you. Yeah, I'd love it. Show me some pictures of those. Wow, did I miss an update or something? It's like, right, it should have given me a warning of some kind, but it's probably because it's all white. So it's just washed out. It's just, do I just stop it or I keep going? I'm gonna keep going and see what it does. My email should be visible on the bio on my page. So you can just send them there. Otherwise, it's going to be dronepowerconcepts@gmail.com. Look at that. We got a 0.10 layer bridge. Right. Oh, it destroyed the bridge. Never mind. You can see in the extrusion that there's gaps. So I think that's really the whole issue at this point. Is it's wetter than it appears to be. Because the other one, I mean, it feels okay, but it feels really soft and really thin. Do you all usually normally just print this at one wall loop? I mean, well, yeah, they're lab print planes. That's what they're designed for, right? You can't go more than one wall loop, or it just ruins the whole thing. You can't put it together. So far, it's ASA when you want to print tissue paper. Oh, I slowed that print down. You guys want me to keep going, or you want me to try something else? Let me know, let me know, let me know. Otherwise, we got an hour and 18 minutes to watch it completely and totally destroy itself. Because I have an idea. Oh my goodness. The AI is just like, I'm asleep. There's no spaghetti. Okay, slowing it down didn't seem to help at all. You would think that it would, though. Unless it lowers the extrusion rate along with the speed. At this rate, I'm not going to have any walls for the top to try and build on. Okay, Carl, I'll check it out right now. Oh, the AI woke up. All right, hold on, everyone. Just a moment. Carl, those are some beautiful looking planes, man. I'm gonna have to, and those are all LW from 3D Lab Print. Okay, so I think at this point what we're going to do is just go ahead and cancel this print. And because it's just going to tear itself up. And I'm going to try something. I don't know. Do we do flow calibration? That might help. We'll try that. We're trying everything tonight. While this is setting up, we'll go into the just chat so you can kind of see. So, obviously that didn't turn out too well. And it came out decent on the vertical for the most part, but that layer height really messed it up close to the end there. So, but it's really fragile. I feel like you could just tear it like paper. So, this could be, again, a byproduct of it being wet or the extrusion ratio that I had on there. But that's what we're here to figure out, right? They're both kind of weak. I don't know if they're supposed to be this thin and flexible, but not with this particular material. Because with standard PLA, it doesn't come out like that. You still get this issue, but for the most part, you don't. I mean, the rest is solid. You know, heavier, but solid. So we're getting there. We're figuring it out little by little. Little by little by little. So I basically just added 11 to the extrusion multiply or the flow rate. Now, I worked with the PLA Aero as well, and I printed the Javelin wings for that project with the PLA Aero. But again, it wasn't a lab print plane. It wasn't a single walled plane. So when the ASA Aero came out, I was like, oh, well, they're making something for lab print style planes. I may have been wrong. But I think once we get the settings correct, I think everything will be fine. I just think that, again, moisture could be an issue. So we may have to pull it and do it again. Because I guarantee you I could print this in like a PETG-CF. You know, and it's just going to come out beautiful. So we'll see how this one works out. That means typically most of the time when I put any kind of generic filament in here, I can run the generic profile and it works perfectly. So why the ASA settings aren't working like they're supposed to is a mystery to me. And I think it's specifically because it isn't geared around the lab print style planes, at least to my understanding. I think it's just an alternative lightweight material for aircraft, but not single wall aircraft, is what I'm saying. So we add that 11 and see what happens. I'm wondering if this flow extrusion also is going to make a difference. So this is going to be interesting. Raise the flow rate, did flow extrusion calibration, and see what happens. It's just spitting it out. There's that ball again. The end. I'll tell you what, I'll be uniquely surprised if just the drying stage solves this issue. I got it again. I got it again. That's all I'm getting off the printer tonight. Little ASA blurps. With the updated extrusion modifier at 55, it looks like we already have an improvement. Whether that helps that upper slope or not, we'll find out shortly. I'm quite curious on how this stuff would react to a different nozzle, like a 06. already looking better. If 055 doesn't solve that top issue, and it may not, we'll find out after drawing, then I may move it up, because it said anywhere from 0.5 to 0.7. So I think it's, every printer is different, even if it's the same manufacturer. So we'll see how it goes. If it doesn't close up that top like it's supposed to, then we will go with a higher flow ratio. And again, we'll be working with drier filament tomorrow. So when we do this again, when we repeat this, we'll do the same thing. We'll see what happens. Looks like we still have some gap splitting at the top on that slope. Anything over 45 just looks like it doesn't want to work correctly, at least in this orientation. But I don't see how you could print this in any other orientation. Down to 5 minutes, and we will compare this one with the other one that was at 0.44 on the extrusion multiplier, and see if there's any real difference in the gaps, because there are gaps on that top surface, trust me. I mean, you can see them from here. And it'll also be a good experiment when we do the drying state to see if the expansion rate changes due to moisture or the absence of the moisture that came out of the pack. All right, 2 more minutes and then we're going to pull this thing off the plate. And yes, that plate comes out hot, so I try and move as quick as I can. All right, give me a second. We'll take a closer look at it. Okay, so from what it looks like, here's the new one next to the old one. And you can kind of see that this is the one that just came off. This is the one we did before at 044. It does feel a little tougher than the other one did. A lot tougher, actually. So, but this part right here is still, while it's a little bit better with a 0.55 on the flow ratio, it's still gapping pretty bad. So we're going to put this through a drying cycle, and I'm going to go with their suggestion on their site for, I'm going to get closer to 0.6, 0.65 possibly, after I test the 0.55 again. But to be honest, I think I'm going to encounter this problem no matter what with this filament. Until we find those proper settings. So, all right, that's where we're at. So, until next time, I hope that you all enjoyed what you did see and what we tried to figure out and what we tried to accomplish, and that you are here tomorrow when we do it again, and we will try to address these issues. I'll do some more research on some settings. And then we're going to continue from there because I want to print this plane. And I want to do it with the Aero, but I want to make sure it's proper. So it will go through its drying cycle tonight. And then we will try this all again tomorrow, probably around the same time, 7, 8 o'clock. So just look for it. It'll pop up sometime tomorrow morning. And then give you ample warning for it. So this... I don't know if this is an issue that everybody faces with when it comes to these particular slopes on these end pieces. Vertical pieces seem like they're going to print just fine. It's those end caps. And if you can get the end cap good, you know your vertical pieces are going to be really solid. So that's what we're working with. I want to thank you all for being here. I appreciate all of you, all the input. And I will see you again next time.